when I'm looking at number 3 up here, I was looking at you showing me that you had the x squared probably plus 4 squared was equal to 7 squared. And you actually had that Pythagorean theorem, square of a plus the square of b equals the square of c above that. And then you had to do it for this side where you had that Pythagorean theorem and you had to show the y. We were looking at 2 perfect squares that added to 17. We said in class 1 and 16 add to 17, which means I have a side length, I have an area of 1 and an area of 1, 2, 3, 4. So this has an area of 16, this has an area of 1. So what are the side lengths? Well, this has a side equal to 1, this has a side equal to 4, and this has a side square root 17. And you could have placed it anywhere. So for the second one, so if you didn't have this right for number 4, some of you didn't correct yours. You should correct yours and put down this right answer for number 4. When we were doing number 5, we were looking for what 2 perfect squares added to 20. And 16 and what are my perfect squares that add to 20? 16 and 4. Which means those are the areas, right, that add to 20. I need the side length. So the side was 4 and 2. And this side is going to be square root of 20, which is what we were trying to get. So they said, show your picture. Do not go on to that other page right now, right? You're working ahead, and I need you to just have this done, okay? So when we are taking a look here, what do I need my side lengths to be? I needed a side of 2, and I needed a side of 4, right? So 1, 2, 3, 4. So then it says label these with points y and z. So this would be my point y maybe, and this would be my point z. So if you didn't have those, make sure you're taking a look at that. Go back and make sure that you have the formula and everything with 1, 2, and 3 also. So if you didn't have that done, when I walked around, I gave you like a score of 3 out of 5 if you didn't have it all done. Maybe a 5 out of 5 if you had everything there. All right, so if we are reading vocabulary, Cassidy, would you please read in our notes?
Rectangle, one right and
Keep going. All that vocabulary.
in a right triangle, the sides that form the right angle are called legs. In a right triangle, the side that is opposite of the right angle is called hypotenuse. Hypotenuse is always the longest side of the right triangle.
So when you're solving any time with our Pythagorean theorem, keeping this is always the longest side. Always, always, always. Always the biggest number across from your right angle, okay? We're going to watch this video and you'll kind of see where they're explaining this, but when we were talking about this in class, we said it's the square of leg A, the square of side B is equal to the square of the hypotenuse. So, as you watch this video, and then just have your notes out.
A more profound link with geometry came from the Pythagorean theorem. In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. In other words, the sum of the areas of the 2 small blue squares is equal to the area of the large square. Here's how the Chinese proved this theorem. Make 4 copies of the original triangle. Put this here for reference. Now slide the triangles around and keep track of the areas of the blue regions. And we see that a squared plus b squared is always equal to c squared. When all 3 sides of a right triangle are integers, they're said to form a Pythagorean triple. Here's one with 3, 4, and 5, and 5, 12, and 13. Another one with 8, 15, 17, and there are infinitely many more. Pythagorean triples were known long before the time of Pythagoras. This Babylonian clay tablet, written around 1700 BC, contains 15 examples of Pythagorean triples, some of the numbers being quite large. No one knows why the Babylonians were interested in these triples, and as far as we can tell, they did not know the general form of the Pythagorean theorem. The Pythagorean theorem appears in Euclid's Elements in Book 1 as Proposition 47. This Arabic diagram shows Euclid's proof. It can be simplified with computer animation. Drop a perpendicular from the right angle to the hypotenuse and extend it to divide the large square into two rectangles. Euclid's idea was to show that this square and this rectangle have equal areas, and this square and this rectangle have equal areas. Animation shows why. All parallelograms with the same base and altitude have equal areas. So all these parallelograms have equal areas, as do all these. And that's all there is to it. So we see that the square of the hypotenuse is equal to the sum of the squares of the legs. Still not absolutely convinced? Make a copy of the small square in the middle of the large square. Make cuts along the sides and out to the edges, and rearrange the pieces. All the pieces from the big square fit exactly inside the other two squares.
So when we did something like this, I am not going to show you today, but I will tomorrow show you the question on the quiz that's worth about a third of the test, where you have to explain this theorem. So kind of going back to this, to the areas, to the puzzle pieces that we were doing on Friday, okay? So we are going to be taking a look, and as you turn in your, at the bottom of this page of notes, if we are reading this. Elijah, you want to read first? Yep, take a long rope.
Take a long rope and tie it to the bottom of the goal pack at one end of a football field. Then run it across the length of the football field to a goal post at the other side. Stretch it tight and then tie it at the bottom. Tie it to the bottom of the goal post so that it lies flat on the ground. Now suppose that I added 1 foot of slack of the rope so that now I can lift it off the ground at the 350-yard line. How high can I lift it up?
So first off, we might want to make sure we're talking about the same unit. So 120 yards, 360 feet, okay? You're going to add a foot. So this rope that goes up here is 361 feet now, right? Whereas going across, if I lay it flat, because we added 1 foot. Does that make sense, everyone? Okay. So the question is, if I stand at the 50-yard line and I lift up that rope, okay, remember I added 1 foot. I'm now going to move the rope in. So here I add this 1 foot, and so now I move the rope out, and I'm going to lift it up to the 50-yard line. Please circle A, B, C, or D. You think it's not high enough to fit my finger under it? Like if I stand there and put my finger under, you think you could get down on your hands and knees and crawl under? Just high enough to walk under? Please circle one of these letters, A, B, C, or D. It's not wrong, but circle one. Or you think it's high enough for a truck to drive under. Okay, let's take a vote. Let's see. A, how many voted A? I can barely put my finger in it. Okay. How many had B? High enough to crawl under. How many chose C? That you can walk under it. So about 5, 6 feet. Okay. How many say D? All right, so I'm not going to tell you yet. We're going to look at the end. But, so you have your answer. At the end of this lesson, we're going to take a look at this. And we're going to see how the Pythagorean theorem can help us find this. Okay? So, here's what we are going to do as you're doing your homework. Your homework is all applying this theorem. And the first thing that I always want you to do in your problems is write down our information. So we start with, find the length of the hypotenuse, this is the top of the next page of your notes, with a leg of 15 inches. So let's put A, right? Our first leg is 15 inches. Now in your homework, it might even be written out this way. A is 15 inches. Then they tell us, oh, the second leg is 20 inches, so B equals 20 inches, which means we're trying to find the hypotenuse C. Should C be more than 20 or less than 20? When I finish, it should be more, right? And if it helps you to draw your right triangle, draw a right triangle. You don't have to, but keep in mind, C is always the longest side. So this has to be greater than 20. So first thing we're going to write, it's square of leg A, square of A, plus the square of B equals the square of the hypotenuse. You guys remember 15 squared from your last test? 225. Plus 20 squared, remember that one for our quiz too? 400. Now, we didn't have to memorize the answer to this one, so it might be helpful if you have a calculator, because some of your numbers are going to get big, and we're going to use some decimals. We get 625 is equal to c squared. I don't want to know what c squared is, I want to know what c is. If I know the area, I take the square root of the area. So I'm going to leave absolute value, or the square root of 625, which when you put it in your calculator, please do that now, don't say it out loud. If you don't have a calculator, there's calculators up at front, please come grab it. Start bringing your calculator with you, you will be using those. Today in class, you will be getting your project back that was in the grade book, and I think we'll get your test back. I still have one person to take it, so hopefully we'll get that done. What'd you get for square root, Addie? What'd you get? 1 to 5. And we would put inches. Is this our longest side of the three? Yeah, and it had to be, right? So when you're checking it, I always need the C to be the longest side, okay? All right. This one starts off and it says the hypotenuse is 15, which means A, B, or C is 15. C equals 15 centimeters. It says a leg is 5, so let's put A equals 5. We're trying to find the other leg. Our answer will be in centimeters. So we're starting with, tell me, Grace, what's the formula we're writing? Grace, I'm sorry. A squared plus, yeah, equals our hypotenuse, right, squared, okay? So as we are looking at that one, tell me, what are we putting in for A? Five. Squared. I'm going to leave it as B squared. Ellen, I'm going to put what for C squared? 15. So we know 25. Hopefully from our memorizing, the 15 squared was 225. What do I have to do in order to solve this one? How do I get B squared by itself? What do I have to do then? Subtract what? 25. Subtract 25 on both sides. So kind of when you were solving your basic equations last year, B squared equals 200. Not a perfect square, right? So what does B equal? You're going to leave me both answers. You're going to say the square root of 200 centimeters approximately. Use your calculator, please, and let's get our approximate answer. And we should have, what'd you get, Nolan? 14.1 centimeters. I would recommend you put both answers when you are doing your homework. Put the square root and then tell me approximately equal. Because sometimes I really want the exact answer, but in a lot of real situations, people don't understand if you go, this length is about square root of 200 exactly. But if you're an engineer or you're building something, you want exact. You do not want to round it, okay? That was the one thing on your project that many of you that I'm handing back, a lot of you told me a lot of it was irrational or was rational, which any formula, anytime we have a formula and pi's in it, your whole answer is irrational, even if you're rounding. Cross off that middle one. And you're going to set these two up. And I'm going to have people come up and show their work up here on the board in just a minute. So you want to start with the formula. So I'm going to start with A squared plus the square of B, side B, is equal to the square of the hypotenuse. Fill in your numbers. Use your calculator. Show your work, right? So I'm going to start this one off for you. use your calculator. You're going to start this one the same way. And once people are done doing theirs, I'm going to be handing out the project while you're looking at this. As I look at your homework, I need the formula. I need this part written out. You're going to show me, oh, that you subtracted what your answer was. And this one should be, actually, for this one, it's exact, right? No approximate. Whereas here, it's an approximate, right? Because it wasn't a perfect square, it was irrational, okay? So, back to our football field problem, okay? So, we gave some lengths. We said that this was 360 feet, right? And now this wire on top is 361 feet. So what we're trying to know is how tall it was, right? We don't know A. Do we know what this side B is? If all the way across is 360, what's half of 360? 180 feet. Do we know what the hypotenuse is, the longest side that we're lifting up? It was 361 feet, so we're going to take half of that also, which is going to be 180.5 feet. Okay, so put that on your picture, please. And what we are taking a look at for this one is we want to know, can we walk under it, crawl under it, right? Can a truck drive under it? So our formula is, if I'm writing it down, Timothy, start me off. A what?
A squared plus B squared equals C squared.
Yep. Next thing with that, as I'm looking at it, I am going to do what next as I look at that problem, Grace? Grace, what am I going to put in? Do I know what A is? Do we know how tall it is over here? So we are going to put, for B, we're going to put in what number? 180 squared. And this is going to be 180.5. So you definitely want your calculator for this one, right? So we're using our calculator. A squared plus, if we are looking at that, take out your calculator and let's write these numbers down. We should have 32,000 what? 32,400. Equals on this side, it comes out to be 32,000. What'd you get? 500. Put it in your calculator, please. 580.25. All right. So I'm looking at my problem and I'm going, okay, this is making sense. What do I need to do next, Trishan? What am I going to do next to get my A squared by itself? Subtract, definitely we're subtracting. I'm going to subtract the 32,400 on both sides. So you should already have this number in your calculator, just hit minus. So when you had 180.5 on your calculator, gave you this, now just hit minus the 32,400. Connor, what'd you get?
180.25.
Okay, so this is the area of the square, right? The question is, what is the side length? So A has to be, not a perfect square, right? 180.25. Approximately, which two perfect squares is it between? 169, 196. So what do we get? About what? 13.4 feet. So this is 13.4 feet. Someone said, how can that be? We only added 1 foot at the end, right? And now you're lifting it way up. So which one can drive on, we should be able to do? The truck should be able to go under it, right? So it seems unlikely that just adding 1 foot to that really long thing, but it makes a huge difference in that this is 13.4 feet. So you cannot just add the 1 to the side and think, oh yeah, it's 1 foot, like I can crawl under 1 foot, right? You don't want to think that this is going up 1 foot. That's not what it said, okay? So it's really key that you're understanding. There's one more example that we're going to look at. and then you're gonna get started in your homework. So top of the next page, you're gonna see this one. As you look at this problem, if you are reading the problem, please, Zach.
You are parasailing behind a boat. After getting airborne and reaching your minimum speed, you are 200 feet behind the boat, and the 300-foot-long tow line is fully extended. How high are you above the water?
So we're trying to find how high above the water. That's a vertical distance, okay? Can it be more than 300? No, 300 is the longest side. So I know that if I get an answer bigger than 300, I made a mistake someplace. So that's kind of what you always want to be thinking as you're doing these problems. So start with our formula, right? A squared plus b squared equals c squared. What do we want to use for a? 200. Could we leave it as a? Yeah, but since b is up here, it makes sense that we should put 200. 200 squared plus b squared equals 300 squared. Now I had someone say, I need my calculator for, no you don't. What's the square of 2? 2 squared is 4, right? You had 2 zeros, this is going to be 4 with, instead of 2 zeros behind it, it's going to have 4. You double the number of zeros, okay? So 200 squared is going to give us 40,000. So 300 squared is going to give us 90,000, okay? We're going to subtract 40,000. I had some people say, I don't get why I have to write all this down. I can just do this on my calculator. The key thing is I can't see on your calculator for all of you at all times. And I will tell you, those of you that got used to writing the formulas, every time we did that area or the volume problems, you did really well on that part of the test. And some of you didn't do so well, right? And I had a hard time trying to give you even 1 point because I didn't have the right formula. So if you didn't have the right formula, is everything pretty much wrong on the problem?
Yeah.
Pretty much, unless you maybe gave me a label at the end. So when you're looking at that, get used to doing it in your homework. And if you do it in your homework, it's going to just make those quizzes and tests much easier. We've not had a homework quiz. You can figure we're probably going to have one this week on working with this stuff. So as we finish this problem, we're going to leave square root of 50,000 feet, but that does not make sense, right? And so we're going to say about 224. I had someone say, well, my answer was 223.6 feet. Can I leave that answer? Yes. Could you round it to 224? Yes. Okay? So here's what you guys are going to be doing as you finish this one up in your notes. You are working on the review, or on this B4 worksheet. There are 2 pages to it, right? So open your workbook to the 2 pages.